Hi, in this video, we're going to learn some of the basics of writing chemical equations. Chemical equations represent chemical reactions. It would be unreasonable for us to write out every chemical reaction using molecular drawings. So instead, we use chemical symbols to represent them. This reaction, for example, can be written as CH4 plus O2 yields CO2 plus H2O. Notice that the compounds on the left-hand side of the equation, what we start with in a chemical reaction, they're called reactants. And what we end up with in a chemical reaction on the right side of the equation, they're called products. Now let's take a look at some of the symbols that you see in this chemical equation. Some of the more common symbols you'll see are for the states of matter. And as you might imagine, gas is symbolized with G, liquid with L, and solid with S. We also have this fourth state of matter, so to speak, and that is the aqueous. Aqueous is another way of saying that the substance has been dissolved in water. So it's a solution. So in a chemical equation, you may hear the terms aqueous, solution, or dissolved in water, and they all mean the same thing. And for all of them, you would use the symbol AQ. Some other common chemical symbols that we'll see are the plus sign. The plus sign in chemical equations means combines or reacts with. Another symbol is the right-facing arrow, which means yields or produces. We never use the equal sign in chemical equations. We only ever use the arrows. Most chemical reactions only can go in one direction, so it would be inappropriate to show an equal sign, which would seem to indicate that the reaction can go in both directions. Another common symbol you might see is the delta. The delta might be above a arrow, and in that case, it means that heat is used in the reaction. Another thing that we use in reactions to get them going are catalysts. So if you see a chemical formula written above an arrow, that indicates that it's a catalyst. Some other chemical symbols that we're going to see will be the double-headed arrow. So some reactions actually can go both directions, and the double-headed arrow tells us that that reaction is reversible. Some less common symbols you might see would be the downward-facing arrow, and that would mean a precipitate has formed. But typically, instead of using the arrow, we would just use the S to indicate that it was a solid. Also, in a likewise fashion, we have the upward-facing arrow, which, as you might guess, would indicate that a gas has formed. But again, we usually just use the G to indicate that. There's one other thing you need to know before you start writing chemical equations, and that is the diatomic elements. There are 7 elements that exist in nature as diatomic elements. Di meaning two, and atomic meaning atoms. And that means whenever you see these elements all by themselves, they're always going to be with a partner. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Of course, I have a way for you to remember them. The diatomic elements can be remembered with the saying, have no fear of ice cold beer. Hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. Make up your own saying if you like, but these 7 you need to know. So when you write chemical reactions, you'll know that you have to indicate that these are diatomic elements whenever they're written by themselves. Now let's take a look at that reaction that we saw in our first slide. Methane reacts with oxygen to form carbon dioxide and water. Methane is probably not a name you recognize. It's an organic compound. When we see it in formulas, you'll be given the formula, or you can simply look it up. Methane is CH4. It reacts with oxygen, and we just learned that oxygen exists as a diatomic molecule when it's by itself. And it forms carbon dioxide, and we've learned that the formula for carbon dioxide is CO2, and it forms water. And you'll notice that very often when water is written, it is not written with its proper chemical formula of dihydrogen oxide, monoxide, excuse me. It's usually just written as water. So let's see again, what does this look like? Here we have our molecules, and here we have our actual formula, chemical equation written out underneath it. So methane is a gas. This is the process that occurs when you turn on your stove if you have natural gas. Methane gas is reacting with oxygen gas, and it forms carbon dioxide and water. Let's take a look at another example. Solid sodium reacts with chlorine gas to form solid sodium chloride. Now, as you noticed in the first example, I like to write in my symbols So I know what I'm working with as I read each sentence. So I have solid sodium, whose symbol is Na, is reacting with chlorine gas. Chlorine is one of my diatomics, so I'm going to remember that. And it's going to form solid sodium chloride. Now, here's where I have to make sure that my charges are balanced, because sodium chloride is a metal and a nonmetal, which means it's an ionic compound. This one happens to be a +1 and -1. So my formula for that is simply NaCl. That will give me a balanced formula. So what does this look like in a chemical equation? I have solid sodium reacting with chlorine gas to form solid sodium chloride. Let's take a look at one last one. Solutions of magnesium sulfate and sodium hydroxide react to form aqueous sodium sulfate and a precipitate of magnesium hydroxide. Well, a lot of big words in that one, right? All right, let's see what we're talking about here. A solution of magnesium sulfate. I know magnesium, and I look on my periodic table, I can see that's going to be a 2+. And I know sulfate because I memorized them. I know sulfate is SO4 2-. So again, this is another easy ionic compound because the 2+ is going to cancel out the 2-. And so for magnesium sulfide, I'm just going to have MgSO4. And it says it's a solution, so I'm going to remind myself that it's aqueous in solution. It's combined with another solution, this time sodium hydroxide. Sodium is a plus, again, from the periodic table. Hydroxide, I know because it's one of my polyatomic ions. This is another easy one because it's +1 and -1. So my formula is NaOH, and again, I'm remembering that it is aqueous. It's going to react to form, so there's my arrow, to form aqueous sodium sulfate. So again, starting with sodium, which is a +1, combining it with sulfate, which is a 2-. Now, if I have 1+ and a 2-, that is not going to give me a balanced ionic compound. So I'm going to need to add another sodium there in order to get 2+ and 2-. So my formula for this is going to be Na2SO4. And it's going to form a precipitate. We learned about precipitates in the last video of magnesium hydroxide. So again, Mg is a 2+, hydroxide I know is a 1-. So when I put these together, I'm going to need 2-, to balance out the 2+ of magnesium. So I'm going to have MgOH2. Remember those parentheses whenever you have a polyatomic ion. Okay, so let's see what this all looks like now put together. I have magnesium sulfate in aqueous solution, combining with sodium hydroxide, also in a solution, and it's forming sodium sulfate, which stays in solution, right? It's an aqueous sodium sulfate, and a precipitate of magnesium hydroxide. Precipitate, again, means that it's going to be a solid. Okay, now it's your turn to practice. So in your OneNote, you have writing chemical equations worksheet, and I'd like you to try the first 5 of them before you come to class on Wednesday.